Hello, everyone, and welcome. I'm Ed. I'm joined by my colleagues Dave, Joshua, and Cherie. We're also joined by our CIO, Dr. Bandy. This is our presentation of our study results from IT services and support operations. Future of cloud computing. My colleagues and I have concluded from various researching that cloud computing will take JED's agricultural business to the next level. We will have security from data breaches, data consolidation, which allows our company to sync information real time and efficiently with other plants. Less cost in maintaining standalone servers and equipment. Collaboration between teams will be more effective with digital technology. This platform will give life to the Internet of Things, which will allow our business to evolve into intelligence agricultural technology. IoT needs a cloud computing infrastructure to function. China is already using cloud technology and Internet of Things to focus on high quality information to meet production needs of farmers. Cloud computing will give us various opportunities in moving into an emerging technology. Scalability will allow greater flexibility. Growth expansions will require less time, planning and training new employees. We can increase capacity with ease instead of costly investments to add new infrastructure. Our focus will be on software instead of hardware. Some cons of future of cloud computing is we'll be dependent upon Microsoft, which could change the cost in the future. High-speed communications will be internet dependence. Communication latency when backing up an entire system. Let's talk about the opportunities in the next slide. After reviewing operational costs over the last 3 years and projections for 2020, some areas for improvement became apparent. Since the majority of JED's business is highly seasonal, requiring the most support during winter and spring quarters, the IT department has procured and supports enough hardware to ensure the highest level of support in the first half of the year. Reviewing the hardware utilization shows that server and support requirements are 40% lower for the summer and fall than what is needed in the first half of the year. We reviewed current trends with cloud outsourcing models and determined there were many cost advantages in utilizing cloud-based services. Some of the benefits include seamless scalability, hardware redundancy, secure data access, dynamic real-time intrusion, virus, denial of service attack prevention, faster OS and database upgrades, redundancy of operation in case of a catastrophic event. For example, if a tornado takes out the server farm in Dallas, there is another system in a city like Atlanta and Chicago running in dark mode that will pick up operations with no loss of service or data. The key advantage is in the scalability. The cloud computing services maintain huge numbers of servers and solid-state drives that create opportunity to run virtual servers that can span across any number of servers while maintaining the integrity of the system. We'll be paying as much as 40% less for hardware use in the second half of the year as in the first half. We can expect significant cost reductions. We'll discuss them later. The risk, the team conducted a SWOT analysis. The key risks include transition costs, successful transition, implementation, reductions in staff issues, backup plans in case of failure, and quality assurance. We'll talk about these later. Spend analysis. We spent $11.9 million last year on IT systems. That was an increase from $9.4 million previous year. Looking at the spending by categories, we're currently spending 61% of the IT budget in IT operations, and within that, 38% is in database administration. We currently have 6 servers, a database administration team comprising of 4 on-site technicians, 2 OS software maintenance support technicians, and 1 programmer. Based on the additional load projected on our current servers, we should consider switching to cloud computing. As mentioned in the previous slide, it is a proven technology, and many Fortune 500 companies have been using this technology for several years. In further slides, we'll talk more about the technology selection criteria and how it help our organization if implemented. The product selection criteria utilized were based on 5 major components: compatibility with JED's business model, JED currently relies heavily on its use of Microsoft applications to conduct its business operation. We sought to find a service provider that would allow seamless transition from in-house server storage to cloud storage, all while supporting our existing Microsoft applications. Cost. Overall cost of operations and transition from in-house servers to storage provided by an infrastructure service provider, we took a methodical approach to comparing cost under our current setup environment to the cloud storage options. The detailed cost comparisons will be visited in later slides. Quality of service. We evaluated quality of service offered from each service provider. We included factors on scalability, bandwidth, proximity. We needed a provider that was able to deliver quick response times on server issues. Security. Data security levels, recognizing that we have a large customer base. We reviewed each firm's security and privacy policies and capabilities to maintain the privacy, integrity, and confidentiality of our intellectual properties and personal information. Change management. Since we operate in a highly seasonal industry, our success requires that our systems are able to quickly adapt and change, both in our software and operating system database system upgrades. We need a service provider that would support this critical function and ensure that any issues are managed and corrected with no loss of business data. After carefully reviewing many infrastructure companies, we found the top two were Amazon AWS and Microsoft Azure offerings. AWS versus Azure. Amazon Web Services, RDS, and Microsoft SQL Azure are leading providers in the market. We have compared the key features of each to select the one that best fits our operations. Microsoft's targeted customer base for SQL Azure are business applications running in enterprise which are using databases of 5 gigabytes or less. Amazon RDS is comparatively more flexible and targets a wider segment of users. SQL Azure allows databases up to 10 gigabytes, while Amazon RDS allows storage up to 1 terabyte per database instant. If we exceed 10 gigabytes while using SQL Azure, Microsoft recommends sharding, which is a type of database partitioning that separates large databases into small, faster databases across multiple servers. The servers that are created with SQL Azure are basically logical containers. These containers will be provisioned exclusively for JEDs and will host only our databases. There is a one-to-many relationship between a physical node in the cloud and the servers you create. Several servers created by different users may be hosted on the same hardware platform in a shared environment. This is known as multi-tenant architecture. For now, SQL Azure supports only a subset of the features with SQL Server. Amazon RDS flaunts complete support for Microsoft features except for replication. In SQL Azure, a notable feature is the databases are automatically replicated across multiple systems, providing for rescale outs, as well as transparent failover mechanism in case of hardware failure. By contrast, Amazon RDS has specifically disabled replication on its MySQL instances. Data in SQL Azure is automatically backed up and restored when a disaster occurs. Then SQL Azure will be a better choice. As the technology would be familiar, we will get Visual Studio integration, support for .NET applications, T-SQL, etc. For all the limitations in comparison to Amazon RDS, SQL Azure is definitely a cheaper solution. AWS RDS will cost an estimated $59,000 a month versus $30,000 a month with SQL Azure. Choosing between SQL Azure or Amazon RDS depends on the type of technology you currently use. If you're primarily a Microsoft shop, as we are, Amazon RDS is a better choice if you have a lamp shop. Why Azure? Considering our current Microsoft-based IT infrastructure, Microsoft Azure is a logical choice for JEDs. Currently, all of our applications are Windows-based and use Microsoft development and database systems. JEDs should have a seamless integration to cloud computing technology. As noted in the previous slide, the cost of a 3-year contract with SQL Azure is much lower than Amazon's RDS. Plus, and very importantly, Azure provides automatic backups of our servers. The three-layer security routing levels offered between AWS and Azure is equal and an improvement over our current security. Another significant benefit of Azure is in the ease in which it allows Visual Studio to deploy new applications. In summary, we find Microsoft Azure Platform to be the best value for JEDs and provide improved speed and support at a lower cost. Projected cost advantage. As you can see in the graph, the cost of server ownership comes down drastically. Downsizing our database team will provide significantly more savings. We project to save approximately $2 million in server costs, over $700,000 in reduced staffing costs, and we'll save another $700,000 in reduced software licenses. In total, we are projecting savings of $3.5 million per year. Risk identification and mitigation. The initial cost and setup fees require a capital outlay of $50,000 with contract acceptance to cover establishing the software OS and Microsoft products. DBase structures and transition import processes for data and email services. The expected returns from the sale of existing equipment is to be around $80,000, which will cover the setup fees and any interest on the funds. Transition. In order to ensure a successful project transition, it is important to appoint an effective project manager and carefully follow the PMI process. Sri is our recommendation for the position, as he is already PMP certified and has detailed knowledge and experience. The project scope must be clearly defined and planned in detail with weekly progress updates. Initial system transfers will be completed between 11 p.m. and 5 a.m. not to slow down current operations. Reductions in staff. Since the cloud servers are maintained remotely and upgrades or support are part of the contract, we recommend a staff reduction of 4 on-site technicians, 2 OS maintenance support technicians, and 1 programmer. This should result in a cost reduction over $700,000 a year. We recommend a reduction be based first on proven skill sets, second on seniority. Backup plans. Both systems will be backed up nightly and all input will be recorded live. If corrections need to be made to the new system, the live data can be updated and the 2 systems brought back into a synchronous state. The server system will provide a dark site running in parallel to it at another location. The vendor will test the system twice annually by switching the site with the dark site and verify the accuracy with the transition. Quality assurance. Both systems can and should be operated in parallel until all reports and data are confirmed to be equal for a minimum of 30 days. Since there will be no changes to the underlying OS databases and service from JED's current system, no change in the programming are expected. Migration timeline to the cloud. First step will be the cloud assessment and risk. This will be completed mid-May. Solution design and security models will both be completed mid-June. Proof of concept will be completed at the 1st of August. The data migration will be completed at the 1st of October. The application migration will be completed mid-November. Acceptance testing will be completed in January 2021, and we will start user training about mid-year and go through to acceptance testing. Our team has discussed this timeline, and we feel like we can beat this timeline by 2 months, which will put our acceptance testing being completed around mid-November. Thanks for listening. We hope you see value in this project so we can move forward.